So now we're going to go through simplifying some more expressions together. So let's do the first one together. Let's first identify our like terms. So 2y and 8y are like terms, and we are going to move them next to each other so that we can better see that. We can move them because of the commutative property of addition. So when we move it, we've got 2y. It's a positive 8y because it's plus. So we may have moved the order, but the values stay the exact same. So now we can see we've got like terms here, y to the first and y to the first. So we add the coefficients. And we have not used this over here, so we keep it. So this is our final answer because there are no more like terms. Okay, no more like terms, so we're all done there. I know this is y to the first and this is y to the first, but this second term has an x with it, so they are not like terms. Alright, so the next one, we've got our like terms. 8x and 12x are like terms, so we add our 8 and our 12. We get 20, and we keep the variable the exact same. Nothing changes there. So let's pause the video, and I'm going to give you an example problem now that I want you to write on the paper. Try it on your own, and then we can check it together. So here's an example, and you need to first identify your like terms. Okay, you can only add and subtract your like terms. So go ahead and try this one now, and then we'll go through it together. So in the first step, we put our like terms right next to each other. So we switch that order, the commutative property, but we have not changed the value of it. So now we can see what our like terms are, and then we can go ahead and combine them. So we've got negative 2 plus 5, which gives us 3. And those x's stay the exact same. That does not change. So now we still had this over here. Still have these terms. Okay, there's no more like terms because we've got x to the first, x to the second, well that's not the same. And then we've got x to the first, but it has a y with it. So again, that is not the same as the others, so no more like terms and we're all done. So one last example to go through together on this page. So I want you guys to go ahead and try this, and then we'll check it together. So we rewrote our like terms right next to each other so we can better identify them. Okay, remember there's a 1 in front of this a. There's a 1 in front because we have one of them. But we're getting rid of it. There's that subtraction sign there. Okay, we move this whole term with it because we could not change the value of it. So we've got 9 minus 1 to give us 8, and then we keep the a to the first the same. This is not a like term, so we just keep it and we're done. So you can go ahead and try these two problems now, and then we can check it with me. Okay, we've got two like terms here, b to the first and b to the first. So we subtract 7 minus 2 to give us 5, and we keep that b. Okay, in number 5, we've got 1n plus 1n plus 1n. They're all to the first power, so they are like terms. So we've got 1 plus 1 plus 1, which is 3, and we have n of them. So we're going to use those like terms now to talk about the distributive property. But before we do that, you're going to get some homework. Okay, it's going to be passed out, or you can go get it if you're doing this on your own. And we're going to give you 5 minutes to get started on it. So 5 minutes to use your notes that we just went over so that it's fresh in your mind. After those 5 minutes are up, we'll transition back to the video to talk about the distributive property. So the numbers that it says to do on the combining like terms individual practice, what you do not finish in class today is to be done for Friday. Okay, and I'll be back tomorrow. So during extended core or lunch and recess, you can come ask me for help. So let's pass that out now and begin working on it if you're working individually for 5 minutes. Okay, now we're back to the distributive property. So product, this means we're going to be multiplying. So we're going to be multiplying A times B plus C. So you should make sure you have this written down. So distribute means we're going to be doing A times B, plus A times C. So A times B means AB, plus A times C means AC. So this is the property we're going to be using. Okay, you're also going to see it with subtraction. So again, product means to multiply. And we're multiplying A times B. Okay, we could also rewrite this as A times B plus negative C. Okay, subtraction is the same thing as adding a negative, which we saw right here. In this problem, subtracting a negative term is the same as adding a negative term. And we also saw that in our warm-up today. All of these problems here on the right were the same. So if that's the case, we've got A times B, and I'm going to rewrite it as plus A times negative C. So A times B means AB plus negative AC. This negative sign can be put out in front. Okay, and if you like it better without that plus sign, you can rewrite it as AB minus AC. They mean the same exact thing. Okay, so let's try simplifying this expression together. We have to use the distributive property, which means we have to multiply this 3 by each term inside the parentheses. So we've got 3 times A plus 3 times 7. Okay, each term inside that parentheses. However, we're not done. We showed that we're multiplying, but we need to simplify. Okay, 3 times A is 3A. 3 times 7 is 21. There are no more like terms, so we are done. So make sure you make a note of that, because a lot of people seem to have trouble with the fact when you get to this step, everybody wants to add 21 and 3 together. You cannot do that because they are not like terms. Okay, let's move down to the bottom one. Okay, we've got the distributive property right here. That means we have 5 times x plus 5 times negative 1. So I'm going to rewrite this problem as an addition problem. So 5 times x plus 5 times negative 1. We have not used this yet, so it just stays here. It is not inside the parentheses, so we did not use the distributive property. So now we need to simplify. So we simplified. Now we got to ask ourselves, are there any like terms? Okay, are there any like terms? Like term and like term. And now there are no more like terms, so we're done. So I know I went a little fast through that, so we can stop to make sure you've written this down, and then we can pause the video so that we can go through it and review it. Okay, there's no sense moving on if we're confused about the steps. So make sure we've written it down and we're going back through it. So pause the video.